Okay, guys, so I'm going to do this problem, and you guys can do these. You absolutely can do these. So, like the last one, maybe it's kind of tricky, but these are pretty much things that I think any of you could do. Okay, so a continuous function g is defined on this closed interval. The graph of g shown above consists of 3 line segments and a quarter of a circle centered at this point 0, 2. Let f be the function given by this. Okay, so find, so f is an antiderivative of g, because this is basically the antiderivative with an integral formula. And most of you actually recognize that, which I thought was awesome. Okay, so it's basically, so you need to recognize this formula. So f is an antiderivative of the input of the integral, which means that the input of the integral is the derivative of that. Okay. Okay, find all values of x in this interval at which f is a critical point. Oh my gosh, and Lucas, okay, I'm talking to, yeah. All right, if any of you thought that this was a critical point, it's because they want the critical points not including the endpoints. So that's why, okay, Lucas and I were talking about that. Okay, so doesn't include endpoints. That's why. Okay, at which f has a critical point. And then we're going to classify each critical point as the location of a local minimum, a local maximum, or neither, and then we're going to justify our answers. So justify, I know when you were taking Regents classes, they would say justify means use math, explain means you use words, but for AP Calc, they both mean to use words. Okay, so, which might be confusing. Okay, so guys, what I'm going to do here is first we're going to write something down. Okay, so we need to know what a critical point is. Okay, so a critical point is like a kind of a vocabulary word. We need to know critical point, and since it's a critical point for f, critical point is where f prime equals 0 or f prime is undefined. Okay, so you need to know that in order to answer this problem. Okay, so now, here we go. So the first thing you've got to do, guys, is recognize this. So f prime of x is equal to g of x, okay? And make sure that you have the same variables here, because I know it's g of t up there. So if you take a derivative of something like this, the derivative is just the input of the integral, so it's that. And it turns out they really want you to say that. Some of you made that observation. It was clear to me that you made that observation, but you didn't state it. This is, just saying this is +1 right there. Okay. Now, I'm gonna, okay, so because of this, I'm looking for where g, okay, so where g is 0 or g is undefined, because g is f prime, okay, because they're the same thing. I'm looking for where g is 0, because it's this graph is defined everywhere. This is the graph of g, and it's defined everywhere. So it's 0 here and there within this interval that doesn't include the endpoints. So critical points, x equals -6, x equals 2. Okay, so let me see how much they give you there. You get another point for saying that. Now, we're going to classify them and justify our answers. Okay, so this is Susan's table stuff. So x equals -6. Okay, x equals -6. All right, so this is g, so this is f prime. It's f prime is here changing from negative to positive. So if f prime is changing from negative to positive, that means that f is changing from decreasing to increasing. So this means, okay, so this would correspond to a local min because f prime, which is equal to g, changes from negative to positive. Guys, you can't say because it changes from negative to positive. You've got to be really super clear about what changes from negative to positive. I learned at this AP workshop I went to 2 summers ago that if you say it, if you're referring to things as it or they won't even read any further. Okay, you've got to be clear about that it's what is changing from negative to positive. Okay, and then x equals 2 local max because at this point g, which is f prime, is changing from positive to negative. Because f prime, which is equal to g, changes from positive to negative. And then there is your third. These together would be your third point. Okay, you can do that. All right, now moving on, we're going to find f of 0. Okay, so f of 0 is equal to, so the way that this function works, the input goes in the upper limit of the integral. So f of 0 is the integral from -8 to 0, g of t dt. Oh, guys, and I'm going to keep doing, maybe I'll keep doing this. I'll write sometimes what you need to know. So you need to know that this means area under the curve. Okay, so that's what you really need to know. So this is equal to, now if we look at this picture, we've got to do the area under the curve from -8 to 0. All right, so I want, okay, I need this area. So we've got to break it up into shapes. And this, by the way, is going to be a negative area because it's below the x-axis. So I've got a triangle. Oh, and then I can do another triangle. I've got a triangle, another triangle, a rectangle, and a quarter of a circle. Okay, so I'll go like this. So I got 2 triangles, so I got to go 1/2 base times height twice. Plus, I've got a rectangle. Plus, I've got a quarter circle, pi r squared over 4. Okay, and I am a, oh, but actually, this will be a -1. Okay, the first triangle is going to be, we're going to be subtracting its area. First triangle area. Okay, so this is going to be negative this, and I'm looking at the first triangle. Oh, let me do, I love placeholders. Really, because I feel like for me it's just easier to fill everything in. Okay, first triangle. Base is 2, height is 2. Second triangle, base is 2, height is 2. Okay, so 2 and 2, 2 and 2. And then for the rectangle, base is 1, 2, 3, 4, and height is 2. Base is 4, height is 2. And then for the quarter circle, the radius is 1, 2, 3, 4. Okay. So we end up here getting -2 plus 2 plus 8 equals, that's going to cancel with that. Oh, no. Sorry. Plus 4 pi. Those cancel. So you end up with 8 plus 4 pi. And I'm sorry to say that's just 1 point. Okay, so they give you 1 point for the answer. Okay, so if you could do those, so right now you're up to 4 points, guys, because you can do this. You could absolutely do these problems. So right there you got 4 out of the 9 points, which is a huge deal. Okay, now this is a limit, and I'm not asking this question enough. Okay, so right here we're doing a limit, derivative, or antiderivative. We're doing a limit. How do you do a limit? You first direct substitute. So this should be f of negative 4 over negative 4 squared plus 4 times negative 4. So this ends up being, okay, so for f of negative 4, it's going to be the integral from negative 8 to negative 4 of g of t dt. Okay, I'm just using this. And then down here we end up with 0, which is great news because, or it's not great news, but so we're going to be stuck if this numerator is also not 0. Because if just the denominator is 0, you know, it's really going to be hard to think about what the limit is. It probably wouldn't exist. But if the numerator is also 0, then we can use L'Hopital's rule. So this is equal to, right now we've got to look at the area under the curve from negative 8 to negative 4. All right? So, guys, we've got these two triangles. We've got this blue triangle, because this here is negative 4. And then we've got this green triangle. Well, guys, they have the same area. So, yeah, we already figured out the area of this is negative 2. The area of that's positive 2. So, together, those areas, like, cancel each other out. So, we do get 0 over 0. Okay, so I'm going to be like this. Let me see if we get anything for that. No. We get nothing for that. But we get a point for what's coming next. So therefore, using L'Hopital's rule, we have ... Okay, so L'Hopital's rule says that since we got 0 over 0, we can get the same limit by doing this. Okay, which is equal to, don't drop the limit, guys. I don't think they'll give you full points if you do. I don't think they'll, and it's not like, you know, they can give you like fractions of a point. It's like all or nothing. So you don't want to lose valuable points that you deserve from just from having poor notation. Now the derivative of f, guys, we already know. So these problems really like build on each other. We've already found this. All right, so you always are going to try to use things that you've already found. And then down here, you can do that. So 2x plus 4. And then you direct substitute over, this ends up being negative 8 plus 4 ends up being negative 4. So g of negative 4, guys, this is the graph of g. Negative 4, the y value is 2. So this is 2 over negative 4 equals negative 1/2. Okay, so you get a point for using L'Hopital's rule. Okay. And then I'm pretty sure you would have had to do, so getting up to here. So all of this is a point. And then you get the second point by that. Okay, so right now, if you feel like you could do this, and I really think, I think you all can, then you are up to 7 points. Okay, now this one, and I really think you could do this too. This is a little bit trickier, but I think you can get some points on this. So let h be the function defined by this. Find h prime of 1. So are you doing a limit, derivative, or antiderivative? You're doing a derivative. How do you do a derivative of this sort of thing? you've got to use quotient rule. So h prime of x equals, so I'm setting up quotient rule, minus all over squared. So g of x goes in here, x squared plus 1, x squared plus 1, x squared plus 1. Okay, so h prime of x is equal to g prime of x times x squared plus 1 minus g of x times 2x all over that. Okay, and we need h prime of 1 equals g prime of 1 times, that ends up being 2, minus g of 1, also 2, all over 4. So all right, let's see if we got any points so far. We got 2 points for this. So that's good. You can do that. We got 2 points for that. Now, the computing this is just 1 more point, and you can do it, this g prime of 1. So I go over here. I'm looking for g prime of 1. All right, so here's 1. I need the slope, so g prime, okay, so g prime is equal to the slope. And since 1 is hitting, since 1 is hitting the graph there, we need the slope of that. Okay, so we would need the slope of that line, because the slope of this line is the slope of the graph at 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the rise, and then the run, we go over 3. Yeah, so that's g prime of 1. Okay, so this is equal to, all right, so this is negative 3 times, let me just write it out, negative 3 times 2 minus. Okay, so now I need g of 1. G of 1. Okay, so this is actually the graph of g. So I go to 1. All right, it looks like that y value is 3. But let me just use the slope to be sure. So down 1, 2, 3 over 1. Yes. Okay. So that is also 3 equals, this ends up being negative 6 minus 6, so negative 12 over 4 equals negative 3. And there is your last point. Okay? There you go. If you're on, you can do that.